fast. So let me start the session. This session is IGF 2024, day 0. This session number is number 167. The title is Inclusion of Unconnected by a Resilient Local Cloud Services. My name is Toshikazu Sakano from Advanced Telecommunications Research Institute International, based in Kyoto, Japan. And first of all, as an organizer, I will talk a bit about the overview of this session and the agenda of this session and some backgrounds to propose this session. So the objective of this session is like this. This session aims to discuss and explore the possibility of local ICT system service with AI to improve disaster countermeasure and to bridge unconnected to connected. The agenda of this session is like this. First of all, I myself will present some background and overview of this session, maybe in 10, 15 minutes. This is followed by the scheduled agenda is the challenges and the possibility solution to provide network for the unconnected in Africa by Mrs. Mary Uduma, who is from Civil Society Africa. But I'm not sure she is joining this session. Ms. Odoma here in this session. So if we confirm the participants, I will ask her to present something. And next one is role of artificial intelligence in bridging digital divide and fostering inclusion of unconnected communities from Ms. Sandra Mahanan, artificial intelligence engineer from Unicorn Group of Companies, Nigeria. And I'm not confirming the presence of her in this session right now, but it's Sandra-san joining this session. So if I confirm the presence, I will ask her to talk a bit about her thoughts. Next one will introduce of extensible frontline augmented communication exchanger crossface and locally accessible cloud system lags by Dr. Babatunde Ojetunde from ATR Japan. And this is followed by the use cases and potential practical deployments of crossface from Mr. Chandra Prakash Sharma, CEO of Westflux from India. And this will followed by the potential use cases of crossface in Philippines and Asia Pacific will be presented by Mr. Jeffrey Lulanto, Executive Director of Central Visayas Information Sharing Network Foundation, CBI Senate from Philippines. And next one will be potential use cases of crossface in Nigeria and Africa from Dr. Jimson Olfe, Contemporary Consulting from Nigeria. This is an overview of the agenda of the session. And after that, we're going to discuss the theme and objective of this to achieve the objective of this session. And in 90 minutes later, we're going to close closing remarks by myself before closing the session. Okay, this is the agenda of this session. Okay, let's go in. So before go into the presentations by panelists, let me introduce brief background of this session and the image I have for accelerating the penetration of unconnected worldwide. So this one slide shows the individuals using the internet worldwide from ITU. In 2024, fully 5.5 billion people are online. That represents 68% of the world population, compared with 65% just 1 year earlier. But 2.6 billion people, one-third of the global population, are still offline. This is a big issue from achieving SDGs. And next slide. Okay, this one slide is a percentage of individuals using the internet in urban and rural areas in 2024, also from ITU. In checking this slide, globally, 83% of urban dwellers are using the internet in 2024, compared with less than half of the rural population, 48%. So of the 2.6 billion people not using the internet, 1.8 billion live in rural areas, against 800 million in urban areas. So people in rural areas, most people in rural areas, especially developing countries, are not connected. This is the issue we need to tackle using the state-of-the-art of ICT. This one slide gives us a hint to solve the issue. This slide shows the percentage of individuals owning a mobile phone and using the internet 2024. Looking at this, globally, 4 out of 5 individuals 10 years old or older on mobile phone. Universal ownership, meaning a penetration rate of over 95%, has been reached in high-income economies. This stands in contrast with low-income economies, where only 56% of the population aged 10 years and over a mobile phone. Looking at the graph, 68% worldwide population are connected to the internet, but 80% own the mobile phone. Well, what's the meaning of this gap? Looking at the, for example, Africa, 38% population is connected to the internet, but 66% of population have mobile phone. So half of mobile phone are not used to connect to the internet. Maybe that they use only for telephone. So here is the hints to fill the gap between connected and unconnected. This is another view of the worldwide. This slide shows the number of disasters by continent and top 10 countries in 2023. And looking at this, most disasters happen in Asia region and Americas and Africa, Europe. And the countries like India, China, Philippines, Indonesia, these countries suffered a lot of disasters. This is also the big issue worldwide. To tackle these issues, I have proposed new concept called LAGS or cross-phase concept. So LAGS, this stands for Locally Accessible Cloud System, is a portable server system which comprises of compact server, access point, Wi-Fi access points, battery, and peripheral devices. LAGS delivers a local social networking service anytime, anywhere, and in any network environment, even in the devastated disaster disruption. Crossface, that stands for Extensible Frontline Augmented Communication Exchanger, is an updated version of LAGS, in which AI functionality is included to support first responders in disasters. So the concept is very simple. We pack small server and Wi-Fi access point within a portable case and running it by battery. So this standalone system can deliver in a local area people the social networking services functions. And users use their smartphones to connect to this small box and use it for sharing the information and chatting and communication. These things the users can do, but area is limited in local. So this is a concept of LAGS and crossface. And very recently, non-terrestrial networks for securing connectivity is becoming popular. So people call NTN, non-terrestrial networks. Maybe Starlink is a kind of them. Draws a lot of attention as a solution to deliver the internet connectivity in the unconnected areas. But LAGS, crossface concept, is considered as a complementary relationship with NTNs because these NTN networks is usefully used for connected to the internet. But LAGS, crossface, is deliver the service local to local people. So from the point of view of internet traffic, you can offload the internet traffic. For the local people, without the traffic congestion, you can smoothly use broadband environment for the local communication. So that is one thing. So this last slide shows the strategy for quick penetration of connected using the local ICT system like LAGS and crossface. In the first phase, in the first step, distribution of crossface of LAGS in an area. Each crossface delivers broadband local internet environment, as you can see in the right-hand figure. In the next step, distributed crossfaces are interconnected with narrowband wireless network. Coverage area is extended to area-wide. Local communication with broadband and area-wide communication with narrowband are possible. So areas are extended to thanks to the narrowband wireless communications. And the third step, at least one crossface is connected to the internet with, for example, a satellite internet service. The area is covered by a global internet. So these steps can help to accelerate the penetration of the internet environment in the rural, especially in the rural areas in developing countries. This is my thinking, and I want to discuss this issue and thinking in this session. Okay, so I hope this session becomes fruitful thanks to the inputs from the wonderful panelists of the ideas and thoughts. Okay, this is my presentation, and let's go into the panel session. And is there any panelists? You have something to say?
I have a question here.
Okay, okay.
Yeah. First question question is related to the price of the crossface equipment. Yeah, the price,
Price,
the cost for
cost.
the for the crossface equipment. It's
Mhm.
the first stage. You, you are talking about development countries that have some people unconnected to the internet.
Mhm.
So we need to have a view about how much does it cost to have this X-face equipment for these development countries. This is the first section. Uh, the second question, this is the first question. The second question is to uh, what what are the keys you consider to decide if it's disaster or not? I see the map of disasters here. For Asia, it is 3 times the disaster in Africa and maybe 1.5 times the disaster in America. What do you what do you what do you mean by disaster?
Disasters?
Thank you.
Okay, thank you very much for your question. Does it work? So I'm trying to show the several slides. Okay, there are two questions. One thing is the cost issue
Yeah.
of crossface. So actually, crossface beforehand, we developed a LACS, locally accessible cloud system. This is a portable standalone social networking service. And this small box with software, we are now establishing the supply chain. And the price right now is 8,000 US dollars per one set.
Yeah.
That kind of cost image we have.
So you will be responsible for the communication with satellite in order to have internet propagated for these areas covered by cross-phase equipment.
Sorry, could you say it again?
Yeah. What I say is uh, this $8,000 for one equipment of cross-phase will cover the cost of interconnection with the satellite.
Um, so I said 8,000 US dollars. This is the first phase. And once start distributing or sales quantity will increase, then cost will decrease,
Yeah.
right? So we are now in the very first phase. So cost or price itself is a little bit expensive, but once start distributing, the cost will dramatically reduce, and that accelerate the distribution. So that is one thing. And second question was the disaster distribution worldwide.
Yeah. What do you mean by this disaster?
Disaster. Uh, I showed. This is not working. Okay, I showed the slide.
Yes.
The disaster means in that slide was uh, typhoon, earthquake, flooding, landslide, that kind of thing, wildfire. So maybe 5 to 10 kinds of disasters are included in that counting. So in these disasters, I hope our ICT solution can help.
Yes.
Because in most disaster situations, the internet cannot be used. Okay, this is the thing. Okay, thank you very much. Okay. Can you use the mic?
You can hear me? I don't know if you can hear me. Can you hear me now? Okay. So my question is for the box, right? The crossface. Do you have to use it only when there's a disaster, or it can work even without a disaster case for remote areas that need internet connection?
Okay, thank you very much for the question. And in the panelists, after my presentation, will give the give the answers. So please ask the table after the panelist presentation. So some panelists are talking about the use cases other than disaster situation. So please wait for a while. Okay, so let's go into the session. Excuse me, are you a participant? Okay, so you must be. huh? So ka. Yeah, yeah. I just attending, not panelist. Okay, I see. Okay, so is there Uduma-san? No? And Miss Sandra Mahana-san here in this session? Okay, so let's go through the next agenda. And next presenter is Dr. Babatunde Ojetunde from ATR Japan. He will talk about crossface more detail. Okay?
Yeah, thank you. Can you hear me?
I hope so. So I need to ask the person.
You can hear me, so maybe.
Yeah, it's fine.
Fine?
Okay. Thank
Okay.
you.
Please show the next presentation. Yeah.
What's his name?
Huh? Tunde. Baba Tunde. This presentation finished.
This finished, right? Okay, okay, okay.
Okay.
You,
Number 2. Click it.
yeah, this one.
The second one.
Yeah, yeah.
Open this. Yes. Full screen. Yes. That's it.
Okay.
Okay, thank you, Dr. Sakano. I am Ojetunde Babatunde from ATR, and today I'll be talking about the introduction of XFIX, or CrossFix as we used to call it. So first I will talk about the challenges of, brief challenges of digital divide in the world. And then I will talk about the concept or the system that we have introduced to address these challenges and show some of the potential use cases in terms of just overview. Then I'll go into our collaboration efforts worldwide. So as introduced by Dr. Sakano, nearly 1/3 of the global population lacks access to basic digital services technology as of 2023. This is often prone to rural area and remote area where there are no internet facilities for people. So there are challenges in terms of educational purposes, healthcare resources through digital means. Also, there are limited access to digital services that can, because there is no reliable internet infrastructure in place. So these are the issues that we try to address in our system in ATR. So I'll be showing some of the systems and some of the use cases. So I'll go into the details now. Okay, so in 2018, we propose a locally cloud accessible system, LACS. This system is a decentralized cloud infrastructure that allow people in a local community or local area to be able to communicate with each other. This project was started from MDRU, then it moves to LACS, and now it has XFACE, which is inclusion of artificial intelligence. It's a portable system that have hardware like a small server, access point, and mobile phone and other devices that can be connected to it. So we created these first to address disaster issue, but it can also be used for other issues like e-education and so on. So I'll move to the next slide. Yeah, so what are the some of the components of what is LACS itself? So LACS is a locally cloud accessible system that provides cloud-like services that is essential for areas that doesn't have internet connection, and it can serve as a mini cloud hub. It functions as a standalone system without requiring constant internet connectivity. It can also be used to deliver essential cloud services to communities, to local communities, through decentralized infrastructure. And as Dr. Sakanu's shows, you can see the interconnection of different LACS or XFACE system. So it can ensure that rural area can have access to digital system in a local way. So this is the prototype of LACS. As we can see, we have a server, a Wi-Fi access point, a battery, a network hub, and it can has a case that you can use to put your mobile phone or tablet. And also it has this case that is very portable. You can easily move it around. So this is the prototype of a LACS system that we first created to address this issue. Next, we'll talk about extensible frontline augmented communication exchanger, CrossFix or XFix. This is an upgrade of LACS to address further issues. We introduced this to be able to include artificial intelligence, which can help in the processing of data faster, and it can allow people to operate it hands-free without having to type. So the AI can accept your speech and transcribe it into text for you, or it can also analyze digital images and so on. So what is XFace? XFace is an upgrade of LACS that have advanced functions, including artificial intelligence. It can, with enhancing communication and information, which enhances communication and information sharing. It operates like a comprehensive local cloud computing platform, and this system is adaptable to meet various local needs and context effectively. So this is an image of CrossFix, as we can see. In this picture, there is a CrossFix with solar panel. So it doesn't only use small battery. Now we have upgraded it to use solar panel, and it can run for more time. So what are the CrossFix architecture and key features? CrossFix consists of a portable access point, terminal, and wearable devices can be used together, as we can see. As you can see at this side, we have tablets, smartphone, and other wearable device. This can be used with XFace, And it also has AI-based information processing and edge computing platform, which we built into the CrossFit's core. And it can also communicate with other external systems, like you can use Starlinks to connect to this. So these are the features and the architecture of CrossFit. Yeah, so now here is the big image of CrossFit. As you can see, we have a solar panel and the CrossFit core, and everything is packed into the CrossFit core consists of devices that are packed into this box so that we can move it around easily. So it functions like a local server that acts as a mini cloud hub for data processing. And also it has an extendable area with communication devices up to 1 kilometer or more if we apply LPWA such as LoRa, Wi-Fi, Halo, and so on. So we can extend the communication range to up to 1 kilometer or more. Also, there is a local speech recognition technology. What this means is that we don't have to connect to the internet to be able to use the speech recognition. We have already built it into the box so that it can process your speech locally. And again, there is an edge computing capabilities that enable that there's real-time processing of data without depending on external system, and this can allow it to function efficiently and manage the data locally efficiently. So what are the other features? It can also support seamless integration with other existing local infrastructure. It can encourage local storage for critical information sharing. It has an AI-driven features for optimizing resources, and it uses a user-friendly interface that allow people to be able to use the software that is processing the information easily. And also we look at integrating learning management into it so that it can facilitate e-education. So what are the AI-driven features that we have? There is a natural language processing that supports multilingual communication. That means it has multi-languages. And also it has an advanced image analysis capabilities for communities where that kind of service is needed. It also uses a geographical information system to show where people are in real time, and also computer vision automation to assess damaged area during disaster, and it can predict risk of damages and so on. So how can we use CrossFit or LAX to bridge digital divide? One way is to use it for e-education. For example, in the rural area where there's no internet connection, we can implement LAX and use it so that students can have access to educational resources, and they can participate in remote learning through the local cloud. The learning management system can enable continuous learning in remote area and can ensure that digital literacy also program can help communities where these kind of skills are needed. So this is an image of the architecture of the LAX configuration that we have done in the past using learning management system that allows students to be able to learn remotely. This will be expanded when we talk about the use cases in Philippines and other areas. So also, we can use it to bridge digital divide by providing a community network. So in a rural area where there are no internet and network facilities, if we interconnect multiple LACs, we can use this to create a community network, as Dr. Sakano showed in his picture the other time. So by connecting one LAC to another and to another and to another, then we can create a local community where people can communicate with each other using this kind of system. And this configuration can use a mesh network prototype to achieve this. So community can gain access to digital skill training, employment opportunities through the platform, and it can also be used for e-health. So where you can do telemedicine services, doctors can connect to the labs in the remote area and can talk to people about their health conditions and so on. So local content creation and sharing can foster cultural preservation in this community. So labs can also be used for other digital services like email, web, and e-government functionalities, where the local government can post some information to the rural people on an electronic board, and they can read it. And this can be transcribed into local languages so that they can understand. So how can we use this for bridging digital device in terms of enhancing community resilience? So for this, as we have heard from Dr. Sakano, disasters are prone to various areas in the world. So crossface can be used as to provide some services so that people can have access to essential information during this period. So it's essential communication can remain in this area that is affected by disaster using crossface and LACs together. So people can still communicate when the disaster occurs. The system also provides automated emergency alert system within crossface, and it can allow first responders to coordinate their activities during crisis situation. Also, local data storage ensures that critical information remain during emergencies. Community resilience is another one, and also telemedicine services can be provided, healthcare information. It can also be used in agricultural system and so on. The last one is disaster preparedness. So this is one of the tests we have done using it for disaster. For example, when we use crossface in disaster, we have 3D image that is mapped into crossface, and when the area is destroyed, we can project back the original image of the area, and first responders can use information from the AI to identify if there is a building in a location, how many people are living in that location originally, and how many people has been reported missing or found in that kind of situation. So now I'll talk about our global impact effort. Through 2018 to 2021, we have standardized LACs, and currently we are standardizing with ITUT the crossface system so that it can have interoperability worldwide and it can be used globally. Other global impact is use case in the Philippines. This will be talk more when we are talking about the use case in the Philippines. And recently, we are expanding the LACs and crossface into other parts of the world, especially Africa. So we had a workshop with people from Nigeria talking about how we can use LACs to bridge digital divide and connect people in Nigeria and other parts of Africa. For future roadmap and collaboration, so we are continuing to carry out research to integrate emerging technologies into the crossface and LACs, and also international partnerships are being formed to scale the solution globally. So partnership opportunity with NGOs, government agencies, and private sectors are encouraged. These are collaborating partners as of now, so we are open to collaboration with other partners from around the world. So, thank you. In summary, that's my presentation. Thank you.
Okay, thank you very much, Dr. Tunde. Okay, so similar presentation about more realistic use cases will be followed. So we will go into the next panelist, and the panelist presentation after that Q&A and discussion session. Okay. So we will go into the next panelist. So next panel is okay. Next presentation is from use cases and potential practical deployments of Crossface. He is CEO of WizFlux company in India. CP, could you start the presentation by sharing the slide by yourself? Okay. Could could you stop the sharing the slide? Yeah. And the online panelists will share the slides and start presentation.
Online?
Online.
Okay. This one?
Uh, one he will present his yeah and yeah yes speak and also share the slides.
give him a co-host.
Uh,
What is name?
and Chandra Prakash Sharma. We call him CP.
Yes, I think this is. Okay, now he is.
So CP, can you share the slide by yourself?
This, no, it's working.
CP, is it possible for you to share the slides? Yes. He is sharing his slide. Maybe this one.
His slide.
His slide is this one.
You want to share it?
Mm.
بالله اسمع
And can you hear his voice? No,
Can he talk? He's not talking, no?
he's talking.
He's quiet.
Mm.
Tell him to speak. Can you speak, sir?
Okay. You want to present the
Yes, yes.
كبر السكرين كبر السكرين
Tell him to do this.
you want to present her presentation, his presentation.
Can you speak? Hi, sir. How are you? Can you speak? Please unmute yourself. Can you speak now? Just do this to him.
CP, you are
What is
muting.
saying the transcription,
Yeah,
taking
yes,
on the
this
screen,
slide.
but his voice is not coming out on the mic, on the speaker.
Okay, let him talk.
Oh,
So
uh,
what he's saying is showing.
We can off.
Okay, so what about the sharing the slide?
There is a slide there.
No, no,
السؤال
his slide.
هو هذا اونلاين عمل له كوست بس هو بده يشير السلايدات تبعه من هون السلايدات ما بعرف شلون يشيرها.
لا هو شايرها. He has the slide. Is he has the slides? Is he has it? Or
Yes, CP, do you share the slide by yourself? Yes, I'm sharing. He is sharing.
حاجة معاه.
He is sharing. He is sharing his slide.
لا بس هو يعني
Now he has the co-host. He has the access to share his slides.
He is sharing the slide.
Yeah. Okay. So we are waiting for him.
Oh, really?
No, he is not sharing. Now he hasn't shared until now. We are waiting.
CP, you are sharing the slide, right? Yes.
Mntwana, yazi into abayifunayo yini?
Sorry.
Don't you ufuna ushare slide from the video there? Yeah, ngiyamuzwa but he's talking lightly. Ufuna ushare slide vele na.
Session time is consuming.
should be able to.
So he has already the co-host. Yeah, he has.
Okay, what did he
He should share his slide.
يعني هو المشكلة عنده.
أيوة طبعا.
We don't have your slides, so you're going to have to share your slides from your side.
Zoom.
You have to share your slides from
Tunnel?
your side.
Yes.
I think we should just go ahead with the session. The audio is not reaching to the session room there, but online participants can hear.
Yes, we can hear you and we can see your presentation, CP. I think the problem is on the local.
Yeah, I can see that some of the participants are there in the room, so I'm not sure if the audio will actually reach them.
Okay. Okay.
Okay.
CP, can you hear me? So the the system is a bit trouble. So we will go into the next presentation by Jeffrey Riranto, and during his presentation, the problem will be fixed. So CP, please do your presentation after Jeffrey. Is it okay?
Okay.
Okay, thank you very much. And Jeffrey, uh,
Can you hear me?
so we will show your presentation slide. So then, please start your presentation. So start.
Will I share
Yes,
my
yes.
presentation to Cezanne or okay, the
So I
first
believe
so
Jeffrey's presentation is shared, and slide slide is changed by the venue. So Jeffrey-san, in your presentation, please say next slide, please. Then Tunde-san operate it. Is it okay? Can you
yes it
can you
yes
hear
it
me,
certainly
Jeffrey-san?
yes I can hear you. Can you hear me, Suzanne?
Okay, so please start your presentation.
Okay, so from the Philippines, I would like to greet everybody a good afternoon, and I hope everything is doing well there in IGF 2024 in Saudi Arabia. My presentation today is building resilient communities through IT-enabled communication with use cases of X-Space project in the Philippines. I'm Jeffrey Llanto of CBSNet Foundation, based here in Cebu, the Philippines. Next slide, please. So just to give a short note, CBSNet Foundation it's an organization that started as a project of the government way back in 1990s to provide immediate internet connection to the entire country. I was working with the government before with the Department of Science and Technology, and we provided the first internet connection to the government, academe, the private sector, and eventually it evolved into a foundation that becomes an internet service provider. So CBSNet is empowering communities. We have proven expertise with 25 years experience in partnership with the government and international organizations such as the Advanced Telecommunication Research of Japan under Dr. Toshikazu Sakano, and also our partners from India with CP Sharma. Next slide, please. So as mentioned, we have local international partners. These are just what we are working together with. We have here ATR and the other partners that we have around the world. Can we move to the next slide? Next slide, please. Can we move to the next slide, please, Tundi-san? I think it's not moving. Okay.
One moment, Jeffrey.
Okay.
I think they are working on the slide again, so sorry for that. Just give us
It's
a
okay.
minute and they will work on it. Thank you.
Now the slide is showing. So You can try to change now, 27.
Okay. Okay, can we go to the next slide, please?
Doesn't seem to work.
So the slide is showing online, but we can see it on the projector to be able to control it here.
Okay, so it's now moving. Can we go to the next slide? The one after that. Next.
I think they're still working on the setup. We may need to add a new track in IGF for fixing the presentations, online presentations.
Jefferson, can you try and change the slide from your side?
What is that again?
Jefferson, can you change the slide from your side? Are you sharing the slide from your side?
Yes, I'm sharing it right now. Can
Yeah,
you
so
post?
you can go on, you can present now. We are seeing it now, so.
Okay. Okay, can you see my slide?
Yes.
Citizen? Okay,
At least we
so
can see. I can see here.
Yes, we can see it here too.
so I'm sharing my slide right now. So let me please continue.
Okay.
So again, going back, CBSNet Foundation, it's a project in the government in the Philippines that evolved into a foundation. It's a self-sustaining foundation that works closely with international organizations like ATR and other organizations. So next is the challenges that we experience here in the Philippines, especially during disaster time. What we have is that island communities, which the Philippines has around 7,200 islands on our country. It is very vulnerable to disaster, especially typhoons. Island schools have limited or no internet access. Then promotion of ecotourism activities and other economic activities in the islands are disrupted. We have unstable and expensive internet connection and unreliable and limited electricity on these isolated islands. Let me share to you some the activities that we have been working with different organizations like NTT and ATR and Flux. So during the time frame of 2011 to our present year right now, we have been working with Japan on research and development effort. Sad to note that everything started with disaster, but we are learning several things on research and development. So everything started during the 2011, the Great Japan earthquake, and also with the 2013, the Typhoon Haiyan, or called Yolanda in the Philippines. We conducted several research and development activities with Japan, which is the Movable and Deployable Resource Unit in 2014 to 2017. Then the Locally Accessible Cloud System 2019 to 2023, and right now the extended uh, project, the X-Space, but before it's called the Frontline Operation System. So the project was launched in response to devastating disaster that struck both countries, Japan and the Philippines. So next, just the timeline again. These are the different activities, and we get different use cases based on the event and also the technology that has been uh, initiated and research and development conducted by our partners from the National Telecommunications, I mean the International Telecommunication Union funded projects and the APNIC funded project in cooperation with different partners like ATR, WISFlux, the Department of Science and Technology. So it started with the locally accessible cloud system in 2019 for its feasibility study. Then 2020, we have the testing and the propagation. Then what happened here during this time in 2020, 21, and 22, there was the pandemic, and we didn't forecast things to happen on that way. So what we did on real-time scenarios like e-learning and the e-health system were then integrated to the LAC system, not as planned, but as what we called as an inbuilt system during real-time scenarios during the pandemic. To give you some overview of the location of the project, it's real time, but we're doing it right now. Meaning we have real scenarios on this one. It's located in the center part of the Philippines. If you notice on the left side, that's the location of the areas On the right side, the map that you can see, there are several islands on it. What we did was to have the connection on the mainland, which is the left side, that is the municipality of Cordoba, in which we have the main point of presence of the internet. The project then pushed that internet connection to another islands. The three islands, these are the isolated islands. Isolated meaning they don't have internet connection, they don't have electricity, much more. They have very limited resources of water in itself. So what we did is the project that we had with Lux and Floss has been tested on the three islands in an area more or less around 10 to 15 kilometers from each other. The execution of the FS in Cebu has different categories, like e-education, as mentioned earlier, during the pandemic. It was a very good use case for us to consider e-education. It was not part of the plan to include it on the locally accessible cloud system, but when we took notice that there is really a need which surfaced during the time of pandemic, in which students cannot go out their own houses or even their own communities, so they rely it on using their smartphones or using their own laptop computers or tablets. So part of it was then developed by ATR together with Risflux to create a system for e-education. Then another category is the disaster response. So we created several use cases for this one, in which the learnings of Lux will also be used as a basis for the next project, which is the X Space. So most of the use cases that we have conducted before will still be implemented on the next research and developments, which is the X Space. So these are some pictures that we have conducted. So on the left side, we can never introduce technology to an isolated community if there's no community uh, interaction or social responsibility. So we conduct social preparation to the communities. Then next is to establish the infrastructure. You can notice on the left side below, we establish the point-to-point wireless connection. Then Dr. Sakano in this picture, together with the frontliners, the one wearing in orange, has been trained using the system below, which is the LUX, and also for floss. And on the right side, you will also notice that this is a very remote area that we have to traverse on small boats to go to the communities. On the bottom right, this is the team that we instructed the faculties of the school, the principal, in how to set it up during emergency, because we want the system to be self-operated and self-maintained by the locals itself, themselves. So we provide the infrastructure. We call it as island infrastructure, where there was a broadband internet connection. If you notice on this slide, where there is very limited electricity, we have to rely on solar power uh, generation for this one in the islands. So we try to use point-to-point connection, and just recently last year we were able to have an internet backhaul using the Starlink connections. So the disaster risk reduction management solutions that we can partner on. So the partner organizations on the top, of course, is Advanced Telecommunication Research of Japan in partnership with Wisflux India. The next one is the government, the Department of Science and Technology. The third one is just recently this year, we have some partnership with unconnected.org to provide low Earth orbit internet connection. Lastly, we just signed a partnership together with the Japan Unmanned Aerial System Industrial Development Association for drone. So we are now looking at the possibility in using drone for the projects that we are going to implement by next year. So the project, again, this is the frontline operation system, which is already X-phase. The government, they have the disaster information system for communities. Then unconnected.org, this is the connectivity to the underserved communities, and JOIDA for the drone training center and certification. In conclusion, uh, as long as disaster always surfaces as a part of challenges to humans, research and development will also go side by side with it. We cannot afford to let go of things as long as there is still a big problem that we need to address. So it started in 2011 during the big disasters in Japan and in the Philippines. So we have conducted several projects in 2014, the MDRU, the LAX, ILET, and XSpace. And hopefully future use cases will be conducted after the project ended with XSpace on 2028. Here, in conclusion, real-time data and scenarios-driven research and development will lead to more innovative products and services that addresses the challenges of resilient communication. So this ends my presentation. Thank you very much, and I would like to hand the table to Dr. Tonde.
Okay, thank you, Jeffrey-san. So time is running, and we have on-site participants from Jeffrey, not Jimson Ofe, doctor, but he needs to join another session from 11 a.m. right? So CP, I'm sorry. Jimson-san will present his presentation, and the slide will be shown by the system. Just wait a minute.
Hello. Hello. Good morning. Greetings, everybody. You're most welcome to this session. I'll be presenting on the extensible frontline augmented communication exchanger XFACE, the potential use cases in Africa and Nigeria in particular. I want to especially appreciate Dr. Sakano and Dr. Jetunde for this program, and also appreciating Jeffrey for that wonderful presentation. In fact, maybe if I say +1 to your presentation and I close now, I think it will be okay, because all that you illustrated capture what I want to talk about. So I also want to appreciate CP. Thank you for your patience. Okay. Now, the XFACE is a beautiful innovation, as created by Jeffrey in that presentation, and it has similar application in Africa and Nigeria in particular. So, two principal areas: number one, disaster management, and on ICT intervention for meaningful connectivity in underserved areas. Okay. Now, with regard to disaster management, based on the 2022 and 2023 reports by the National Bureau of Statistics and the National Emergency Management Agency and the United Nations Development Program, flooding is the most common and recurring disaster in Nigeria. Oh. I think, and it's like I pressed too hard. Need to go back. Need to take it back. Back. Yeah, it's okay. Yeah, so the Nigeria Impact of Flood Recovery and Mitigation Assessment Report 2020 revealed the overwhelming effect of floods on livelihood, businesses, housing, agriculture, and food security, education, and health in Nigeria. Yeah, next, please. So X-Face can be used in the known disaster, areas for frontline responder, so that the concerned authorities can take charge. Concerned authorities at the national level, state and local government level can take charge of disaster management. With X-Face, more on-site information can be gathered for back office analysis. It can enable information sharing and comprehensive documentation of the experiences of victims of flood for improved risk mitigation strategies. Next, please. I believe this diagram has been shown earlier, but this is the schematic of the X-Face. To the left, I want to see if I can illustrate better. Excuse me. I want to see if I can grab my pointer. Yes. So to the left, you have the frontline responders, the disaster area, and they have a smartphone and a tablet. And with these devices, they can use it to capture events, exact situation that happen, and it will flow to the X-Face. The X-Face is like a bus, that is the main engine, and then the information will be captured automatically, and objects can be analyzed, can be identified based on even data that have been captured before. And as such, it interfaces with the cloud. It interfaces with the cloud, and so we have a kind of intelligence system that accumulates data over time. So this helps ensuring that we retain memory, proper analysis of what had happened over years, so that we can learn better. Next slide, please. Next slide. Okay. Now, this is the full architecture. So in the architecture, you have the smartphone and the tablet. First responder can also use the smartphone. There are also wearables as well. And the information therein will go into the server system, and with AI processing capacity. So objects, activities are recognized. And it can also connect. Of course, this end is the X-Face. The X-Face will be around the field area, and it also interfaces with the cloud system, so which is a database backup, and that has cumulative memory of all form of activities that happen, and it can help with recognizing faces, recognizing areas and victims. Next slide, please. Okay, so that was for disaster. The X-Face can be used for disaster management. Now for ICT intervention, which lines up with this Global Digital Compact, the objective of bridging the digital divide, just like Jeffrey mentioned earlier. X-Face helps with ICT intervention for meaningful connectivity in underserved areas. For example, 75% of Nigerians are connected to the internet, according to the Nigerian Communication Commission. That is March 2024 data. It means a quarter of Nigerians are still unconnected in many underserved areas. In this scenario, X-Face can be deployed. More serious disconnect exists in many African countries, where it's 75%, but there are other countries that are even 11%, 22% in Africa. Okay, so it's a huge gap. X-Face will help to bridge the divide, indeed. Next slide, please. And so it can enable shared internet connectivity in those underserved areas, provide a platform for community information sharing, provide a learning portal for inclusive learning in the concerned areas. This is relevant for targeted e-learning programs so that nobody is left behind. Okay, next. So X-Face has the potential to change the narrative, with regard to how we manage disaster, either in Nigeria or by extension Africa, even around internally displaced person camps and our underserved areas with meaningful connectivity to the internet for communication and e-learning. So that is briefly about the potential use of X-Face in Nigeria and Africa generally. Thank you very much for listening. Thank you, CP, for giving me the opportunity. Thank you, Dr. Sakano. Thank you.
Thank you very much, Jameson-san, for your time. Okay, so time is running, and last panelist presentation by Chandra Prakash Sharma, Mr. So, okay, I need to talk to the staff. So, CP, can you present by sharing the slide by yourself?
Yes, I have started sharing my slides. Please confirm if you can see.
Okay, CP, just a second. The room is not. So now, online. Okay, CP, we are very, very sorry. So the next session will start from 11:15, 5 minutes from now. So we need to wrapping up this session.
Okay.
Thanks to
Yes.
the system trouble.
Mm.
So I will think about sharing the people who are interested in our work. So please, please forgive me by
Of course.
not not,
No, no,
not good
like that.
managing of the this session.
Yes,
So
yes.
I need to wrap up this session because of the time. So next session will start in a few minutes. So in this session, we are discussing and presentation the potential of ICT system, portable one, for disaster countermeasure, and also fill the gap between connected and unconnected. But working is going on. We have networks here, and we have several participants who are, I believe, interested in activities. So we will extend the network through this session. But the time is up. So thank you very much for your participation, and I'm sorry the my time management. So now session is closed, and the people on-site participants, please discuss after this session with me. Okay. Okay. So thank you very much, everybody. Session is closed. Thank you very much.